Exercise 8.1, exponents. When we're talking about powers and exponents here, we're going to start with some vocabulary here you need to be familiar with so that when we're talking about these things, you understand what it is we're talking about. A power is made up of two things. It's made up of a base and an exponent. The exponent tells you how many times you are going to multiply the base by itself. So right here is our power. Two parts that it's made up of is the base and the exponent. The exponent again telling us how many times we're going to multiply that base, a times itself. 6 to the second power can be written like this. Could be also said to be 6 squared, which means that we are taking 6 times 6. Okay, we have shortcut ways of naming certain powers, which we're going to talk about here. Other ones we would just read as the initial one here, 6 to the second power. Usually you would hear that as 6 squared. Same thing with something to the third power. 8 to the third power can be written in power form as 8 with an exponent of 3. It is also read as 8 cubed, which means we are taking 8 times 8 times 8. So anything to the second power is said to be squared. Anything to the third power is said to be cubed. Some rules of exponents. Multiplying. Anytime we multiply like bases, you add exponents. These are rules with exponents that you have to understand. Okay, you're going to see them over and over and over again, not only in here, but in your Algebra 2 class. You need to know these rules. Multiply like bases, add the exponents. So 2 cubed times 2 to the 4th, add the exponents. 3 plus 4 is 2 to the 7th. Put that into your calculator. When we put these into our calculator, 2, your exponent key is your up arrow key here. On some calculators, it may be an X to the Y key. If you don't know where your exponent key is, you need to ask me that in class so I can show you how to use it on your calculator. Otherwise, you plug it in just like that. 2 to the 7th power is 128. 5 squared times 5. Just like decimals. Remember, when we have decimals, if there is no decimal given, the decimal is understood to be after the number. If there is no exponent written, it's understood to be an exponent of 1. So we have to add exponents here. 2 plus 1 gives us 5 cubed. In your calculator, 5 cubed, it's 125. X to the 6th times x squared. Add the exponents. I get x to the 8th. Division involving exponents. And this division rule we're going to talk about, but I like thinking of it in another way, which we will talk about as we're going through these problems. A to the m power over a to the n. Now we subtract exponents, and this should make sense to you. Remember, multiplication and division are opposites. Addition and subtraction are opposites. So if we're multiplying like bases, we add the exponents. It should make sense that if we're doing the opposite and we're dividing the bases, that we're going to do the opposite of adding them, which is to subtract the exponents. So 3 to the 5th over 3 cubed. You could simply subtract and go 5 minus 3, and that is 3 squared, which works nicely if the numerator has a larger exponent than the denominator. Otherwise, you're going to introduce negative exponents, and then we have to talk about moving things. The way that I like to think about these is, remember, the exponent of 5 tells us how many times we are multiplying that number by itself. So up top here, 3 to the 5th really means 3 times 3 times 3 times 3 times 3. In the bottom, 3 cubed means 3 times 3 times 3. Where do I have more 3's at? In the top. How many more? 2 of them. That's how we get 3 squared. Let's use that same thought process here. 6 to the 4th means 6 times 6 times 6 times 6. So 6 times itself 4 times. Divided by 6 to the 7th. 6 times itself 7 times. Where am I going to have more 6's at? In the top or the bottom? I'm going to have more down in the bottom. How many more do I have in the bottom? 3 more. So that's 1 over 6 cubed, or 1 over 216. A to the 8th power over a squared. I have 8 a's multiplied in the top, 2 of them multiplied in the bottom. I have more up in the top. How many more? 6 of them. So I get a to the 6th power. Raising a power to a power. X to the m power, all raised to the n power. Anytime we have a power raised to a power, we multiply the exponents. So 4 squared raised to the 3rd power, I take 2 times 3, which is 4 to the 6th. 4 to the 6th power is 4,096. 3 cubed raised to the 3rd power is the same as 3 to the 9th power, and 3 to the 9th power is 19,683. A to the 4th, all raised to the 5th, multiply 4 times 5. That means that that is a to the 20th power. Raising a product to a power. Now, these next rules are really the same as the rules we just talked about. Product to a power. Same rule that we just had. It's really just the same as a power to a power. The only difference is I need to take every exponent inside these parentheses and multiply it by this exponent outside. So I get x to the mp times y to the np. So we simply take and apply that exponent to everything inside when we have a multiplication. So in this case, 3 times 4 to the 2nd power, 2 different ways we could do this problem, and I'm going to look at it both ways here. If we simply follow order of operations, what do we do first? Parentheses. So do parentheses first. 3 times 4 is 12. So now we have 12 squared. 12 squared is 144. If I was doing that problem, that's how I would do it. Okay. You can also use this rule here and take this exponent of 2 and apply it to both things. That would be 3 squared times 4 squared. 3 squared is 9. 4 squared is 16. And 9 times 16 is 144. Does not matter which method you use. Same thing here. We could follow order of operations. Do everything inside first. I'm going to use our exponent rule here just so you get used to using it. I need to apply this exponent on the outside of 3 to both of these exponents inside. So that's going to give us 2 to the 9th power times 3 to the 6th power. 2 to the 9th is 512. 3 to the 6th is 729. Multiply those together. We get 373,248. Last one here, 2x squared, y squared, all to the 3rd. Most common mistake that would be made in this problem is students would take the 3, they would apply it to the exponent of 2 on the x and the exponent of 2 on the y, and forget to apply it to the exponent on the 2 out in front. This exponent of 3 has to get applied to all 3 exponents in this case. Remember, there's an exponent of 1 there. So that's 2 cubed, x to the 6th, y to the 6th, simplify 8x to the 6th, y to the 6th. Raising a quotient to a power. Basically the same rule that we just talked about. If I have a quotient inside, I need to take the exponent on the outside and apply it to every single exponent on the inside. This only applies for products or quotients, though. If there's an addition or subtraction in here, you cannot use that rule. So we get x to the mp over y to the np. So in this case, 3/4 squared. Need to take the 3 and square it. Take the 4 and square it. We get 9 over 16. 1 cubed over 2 squared, all raised to the 4th power. Apply the exponent of 4. We get 1 to the 12th over 2 to the 8th. 1 raised to any power we know is 1. And 2 to the 8th power is equal to 256. X cubed over y to the 4th, all to the 3rd. We get x to the 9th power over y to the 12th power. Nothing else we can do to simplify there, so that's all we can go do in that problem. Negative exponents and zero exponents. Negative exponents should not be that difficult to work with. We can always make a negative exponent positive by simply moving it along with the term it's attached to, either to the top or the bottom of the fraction, depending on where it currently is. In this case, a to the negative n power. I have a negative exponent on something up top. I can take that whole term, move it down to the bottom, and the only thing that changes is the sign on the exponent, so this becomes 1 over a now to the positive n power. If that negative exponent starts down in the bottom, in this case I have an exponent of negative m on b, take that whole term, move it up to the top. The only thing that changes is the sign on the exponent. We get b to the m power. Last property, property of 0. Anything to the 0 power is 1. It does not matter how big the number is, how small the number is, how many variables there are. If it's raised to the 0 power, by definition, it is equal to 1. Rational exponents. Remember, the word rational simply means can be written as a fraction. All the same rules for integer exponents apply for rational exponents. So don't think that there's a separate set of rules if you see a fractional exponent. You're still going to do exactly the same thing. So in this case, 3 to the 1/4 power times 3 to the 3/4 power, you're simply multiplying like bases. So don't let the fractional exponents throw you off. Follow the same rules. You have a calculator to do the fractions in. Take the time to plug it in. 3 to the 1/4 times 3 to the 3/4. Multiplying like bases, add the exponents. 1/4 plus 3/4 is just 1. 3 to the first power is 3. A cubed, b to the 6th, all raised to the 1/2 power. I need to take that exponent of a half, apply it to everything inside. So I get a power to a power, we multiply. So a to the 3/2, b to the 6/2. Simplify, can't simplify that fraction, but 6/2 is the same as 3, so a to the 3/2 power, b cubed. All right, putting some of these together here now. First problem here. When it's just numbers, you can either choose to follow order of operations or use your rule of exponents. It does not matter. I'm going to use the rules since that's what we're working with. This is a power to a power twice. So I get 3 to the 4th because we're going to multiply, times 2 to the 6th, 3 to the 4th. Plug that into your calculator. 2 to the 6th. Plug that into your calculator. We get 81 times 2 to the 6th is 64. And 81 times 64 here we have multiple things going on. I would get used to following order of operations here. Okay, so what I'm going to do to begin is I'm going to simplify stuff inside the parentheses. Inside the parentheses here, look at each part separately. Look at the 2's. 2 squared over 2 to the 4th. Where do I have extra 2's at? Down in the bottom. How many extra? 2 of them. So I have a 2 squared left there. The 3's. 3 to the 5th over 3 cubed. Where do I have extra 3's at? In the top. How many extra? 2 of them. Now I have a power raised to a power, so up top I get 3 to the 6th because we're going to multiply. In the bottom, 2 to the 6th. Simplify that. We end up with 729 over 64, and we cannot go any further. Follow the same rules here. Simplify inside the parentheses. X cubed over x to the 5th. Where do I have extra x's at? In the bottom, how many extra? 2. Y to the 7th over y cubed. Where do I have extra y's at? In the top, how many? 4 of them. Now I have exponent raised to an exponent. Multiply. We get y to the 20th over x to the 10th. Last one. This is a big one as far as calculator. Make sure right now on your own you are plugging this into your calculator. You should get negative 1,000 296. The biggest thing that you need to understand here, you have to be able to use parentheses properly on your calculator. That and that do not equal the same thing. This is saying take 2 and square it, because we have to do exponents first, then multiply by this -1 out front. That is equal to -4. This is saying take the value of -2 and square it. That is equal to +4. So make sure that you know the difference between these two things. So here with the -3 to the 4th power, that's actually going to be a negative value times a positive value here when we have -2 to the 4th. That's how we get a negative solution.